In this video, we're going to talk about current, voltage, power, and resistance. Electric current is kind of a weird one. They call it current, which is a C, but its symbol is actually an I, and it's just the flow of charged particles, or the rate at which charges pass through a given point. And then its units is amps. So we have this thing that starts with a C, and its symbol is I, and then its units are amps, which is 1 coulomb per second. So this is kind of weird, so just keep that in mind. Conventional current, they call that the flow of positive charges, the positive charge is flowing to the negative charge. And again, in most metals, the electrons are actually the ones that are moving, but it gives the appearance that the positive charges are moving. So that's kind of confusing, so just keep that in mind. The potential difference, they know that's known as the volts, so you'll say, it'll say like a battery with a volts of whatever, and that's the potential difference. And this one is easy. Some of them are hard like current. Volts is easy. It's voltage, and it's measured in volts. Power, this is the same power that we were talking about back when we were talking about work. So again, it's just that rate at which energy is transferred, and so it's still measured in watts, and it's a joule per second. Except now in electricity we have power equals current times voltage, and you can put this in the triangle. This is like the worst triangle ever created, but you can put this in the triangle if you want to. So for this problem, we have a battery that is 6 volts. So we will write that down here as a volt of 6. And then it says that it's delivering a 0.5 amp current. So again, even though it's current, our symbol is I, and it's 0.5 amps. To an electric motor connected across its terminals. And then it wants to know, what is the power delivered to the motor? So we want to know the power. And so we're going to use our power formula. Power is equal to I times V, or current times voltage. And we don't have to put it in the triangle because it's already in a form that we like. So we can just go ahead and do our math. So we'll have our current of 0.5 amps and our volts of 6. And we'll get 0.5 times 6 is 3, so we will get 3 watts as our answer. And that's all you have to do. It's pretty simple compared to some of the things that we've done in the past. Now resistance. Resistance is opposition to current caused by any material or device. So like your hair dryer will have a resistance, or a light bulb will have a resistance. Anything will have a resistance. And resistance is measured in ohms, and it's this cool little symbol. And it's just a volt per amp. And a resistor is just something that is designed to have a specific resistance. So if you want a specific resistance in your circuit, you can put a certain resistor in, and you'll get what you need. And this is the equation that we use. Our resistance is equal to volts divided by current, and this is known as Ohm's law. So I would know what Ohm's law is, and I would just like Newton's second law is F equals ma, I would know that Ohm's law is R equals V divided by I. So now, let's try another problem. We have a 30-volt battery. So our volts are 30. And we have a 10-ohm resistor. It's this cool little symbol. And then we want to know the current through the resistor. And again, even though current symbol is an I, its units are an A. And so our formula is R equals V over I. And we can actually put this in the triangle. I have to be like the worst triangle drawer in the history of people that draw triangles. And so we have this. And again, we want the current, so we can cover that up because that's the one we want. And so we'll have current is equal to volts divided by resistance. So then we can go ahead, we can plug in our volts. They're 30. And our resistor is 10. And so 30 divided by 10 is just 3. And the units for current are amps. So 3 amps. And that's all you have to do.